Hello everybody, welcome into another lesson. So today we're going to talk about quadratic functions. Quadratic functions, the degree of the equation is always 2. It's always has the highest power in the equation being to the second power. The general form of a quadratic function is f of x equals ax squared plus bx plus c. You may have seen this before when f of x was y, when we were doing stuff with solving quadratic equations before. But the general form is f of x equals ax squared plus bx plus c. Now, here what we have is the graph of the most basic quadratic function f of x equals x squared. That has a coefficient, of course, of 1. A is your coefficient on the x squared term, B is your coefficient on the x term, and C is your constant term. Well, f of x equals x squared, your A is 1. That's your coefficient on x squared. You have no bx, or C term. So this is your most rudimentary quadratic graph. Whenever you graph a quadratic function, you get a shape called a parabola. That's what you're going to get every time. Now, if the constant, the a term on your x squared term is greater than 0, it opens upward, like the f of x equals x squared does. Now, if your a, the constant on the x squared term, is less than 0 or negative, this would flip and it would open downward. So, if this were f of x equals negative x squared, this would be flipped over and it would open downward. Now, some things about the graph of a quadratic function. The lowest point here, down here at 0, 0, that's the vertex. In general, to find the vertex of a quadratic function, you take negative of the b coefficient on your x term over twice the a coefficient on your x squared term. That'll give you the x coordinate of the vertex. To find the overall coordinate of the vertex, you keep the negative b over 2a. Your y coordinate is f of negative b over 2a. Then you have what's called the line of symmetry, which is also x equals negative b over 2a. A line of symmetry. So you may or may not have heard the term symmetric before. Basically, through the point of symmetry, it's like you could take this parabola, you could fold it in half, and it would fold in on itself. You would be able to fold it in on itself, and it would be identical when you fold it over. That's what the line of symmetry is. And also to find the maximum or minimum value of a quadratic function. So this is all going to come into play, okay? Because what's going to happen here is when it opens upward, you're going to have a minimum value at the vertex. If it opens downward, the function's going to have a maximum value at that vertex. So the maximum or minimum value of the function is f of negative b over 2a. So we're going to get started here with some examples, and I'll walk you through it. I know this was a lot to take in at first. As I warned in the previous lesson, quadratic functions are quite a bit more. They're quite a bit more to deal with. And this is a little preview of Algebra 2, where we'll get into other types of functions. But quadratic functions do come up in Algebra 2 quite a bit. So that's just some good practice here for when we reach that point. Alright, what is the first example? Let's say you have f of x equals x squared minus 5. So you have f of x equals x squared minus 5. Well, first thing you want to do with a quadratic function is you want to find the vertex. Always find the vertex. So, we're going to start with finding the vertex, which is going to mean x is equal to negative b. Well, b would have to mean that there's a bx term, or there would have to be a coefficient with an x to the first power term. There's nothing. So in this case, it would be negative 0 over 2 times the a term, the ax squared term. The coefficient on the x squared term is 1. So you have negative 0 over 2 times 1. Well, that's just going to be 0. We got the x coordinate of the vertex. Now we need to find the y coordinate of the vertex. In order to do that, you just simply put in that x value you got into the function. That would be f of 0, which would have to mean you put in 0 to the second power minus 5. Well, 0 to the second power is 0, so you have 0 minus 5. So f of 0 equals negative 5. So the coordinate of the vertex is going to be 0, negative 5. So 0, negative 5 is the vertex of this function here, the quadratic graph. So 1, 2, 3, 4, 5. There's the vertex at 0, 5. 0, negative 5, excuse me. Now, if they're asking for the line of symmetry, that's also going to be x equals negative b over 2a. Well, that's at 0. So the line of symmetry is at x equals 0, which would be the entire y-axis. That's the, this is x equals 0 is the entire y-axis. So that is your line of symmetry. So we got that. In fact, let's write that. Line of, we can abbreviate it sim, is x equals 0. That's the line of symmetry, which would go straight through the x-axis. Now, since the coefficient of the x squared term is positive, this parabola is going to open upward, which means we have a minimum value. The minimum value is f of negative b over 2a, which in this case was f of 0. F of 0 is negative 5. So the minimum value of this function is going to be negative 5. That would be your minimum value, is negative 5. Now, something else you'll want to do, last but not least, is set the function itself equal to 0 and solve for the value of x. Let's do that over here. So set the function itself equal to 0. Take that x squared minus 5, set that equal to 0. Well, then you would get x squared equals 5. X would equal plus or minus the square root of 5. So your x-intercepts are going to occur at negative square root of 5, 0, as well as positive square root of 5, 0. Alright? So now let's plot the points at those 2 points. Negative square root of 5 is a little bit smaller than negative 2, so that's going to go about here. And then positive square root of 5 is a little bit greater than 2. That's going to go about here. Now we've got sufficient points. We can go ahead and connect the dots and draw a nice parabola. And what do you know? We have graphed f of x equals x squared minus 5. So start by finding the vertex, which is going to be x equals negative b over 2a. And then to find the y-coordinate, you put that value in for the function. I got f of 0 equals negative 5. The line of symmetry is x equals 0, because it's also x equals negative b over 2a, which is 0. To find the minimum value of this function, it's just that f of 0 equals negative 5. And then you want to solve for the x-intercepts, and then you just connect the dots and you draw your parabola. That's really all there is to it. And I got more. I do have more. Alright. We have g of x equals x squared plus 4. So this particular function, we have g of x equals x squared plus 4. So let's start again. Let's find the coordinates of the vertex, or the coordinate of the vertex. There's only one vertex, I should say, or vertice for the plural form. So that's going to be x equals negative b over 2a is how you find your vertex. Well, the b term, there is no x to the first term, so that goes right away to 0. You have negative 0 over 2 times your coefficient on the x squared term is 1, so that means x is 0. We found the x-coordinate of the vertex is going to be at x equals 0, which, by the way, is also your line of symmetry, is at x equals 0. So again, your line of symmetry is the entire y-axis. Now, we want to find the y-coordinate of the line of symmetry. You just put that value in you got for x into your function. So this will be g of 0. That's equal to 0 squared plus 4, which means that's 0 plus 4. So g of 0 equals 4. So the coordinate of the vertex is going to be at 0, 4. So 0, 4 is going to be your vertex. Okay, so we've plotted the vertex. Now, we have a line of symmetry established at x equals 0. So that's the line of symmetry. X equals 0 is the entire y-axis. Now, we also want to find the minimum value of the function, which is going to be the value of g of 0 equaling 4. So the minimum value, since the coefficient on the x squared term is positive, this graph is going to open upward, which means the vertex is your minimum value. So the minimum value for this function is going to be 4. Now, next thing you want to do is find the x-intercepts. But we're about to see something very interesting here. So set your function equal to 0. Your x squared plus 4, set that equal to 0. Well, you would end up getting x squared equals negative 4. So x would equal plus or minus the square root of negative 4. Well, here's the problem with that. We got one problem. There is no real number solution to the square root of a negative number. Because if you take any number to a second power, you'll never get a negative number. Never. So we have no x-intercepts on this one. Now, when we get to Algebra 2, on the other hand, this would be considered an imaginary number. And we'll deal with imaginary numbers at that time, but we're not dealing with those in Algebra 1. So we can clearly see there's not going to be an x-intercept. Well, how do we find sufficient points? What I'm going to suggest is that we pick any other point for an x value and then we plot it. So let's say we take g of negative 1, right? Let's pick x equals negative 1. That would have to mean you get negative 1 to the second power plus 4, which would have to, negative 1 to the second power is 1 plus 4, which would equal 5. So you get the point negative 1, 5. So negative 1, 5 lies on the graph here. We can plot that. Now what if we took g of 1? G of 1 is equal to 1 to the second power plus 4, which means that's equal to 1 plus 4, which means it's equal to 5. So the point 1, 5 also lies on this graph. So let's go ahead and plot 1, 5, which will be right there. Now we have our 3 points. Let's go ahead and connect it with a nice parabola. And since this has a positive coefficient, we can see the parabola opens upward. So that is the graph of g of x equals x squared plus 4. Alright, what is the next one? Good one. H of x equals x squared minus x minus 6. So we have h of x equals x squared minus x minus 6. So once again, start by finding the vertex. So to find the vertex, you take x equals negative b over 2a. Well, the b coefficient, which would be your x to the first term, the coefficient on your x to the first term is negative 1. So you'd have negative of negative 1 over 2 times the coefficient on your x squared term, which would be 1. Well, negative 1 is positive 1 over 2 times 1, that's 2. So the x-coordinate of your vertex is at 1/2, which also means your line of symmetry is at x equals 1/2. And I'm going to draw a little dotted line here at x equals 1/2. So that is the line of symmetry, is at x equals 1/2. Now, to find the y-coordinate of the vertex, I'm going to put that value of x into the function. So we're going to take h of 1/2. We're going to put that into the function. That would give you 1/2 to the second power minus 1/2 minus 6. Well, 1/2 to the second power is 1/4. So you have 1/4 minus 1/2 minus 6. Well, let's see. You'll end up having 1/4 minus 2/4 minus 24/4. So we want to convert these all to the same denominator. So 1 minus 2 is -1 minus 24. You would get -25/4. So the vertex, I'll call that point V, is going to be 1/2 -25/4. That's going to be your vertex. Is going to be located at 1/2 -25/4. So I found the x-coordinate of the vertex by -b/2a. Then I simply just put that 1/2 value in for the function, and I came up with -25/4 for the y-coordinate. So therefore, the vertex is located at 1/2 -25/4. Well, -25/4 is a little bit smaller than -6. So there's my -1/2. That's going to go right about there. That's going to be the vertex. There's my 1/2 -25/4. Now, we have found the vertex. We found the line of symmetry. The minimum value is, of course, h of 1/2, which is -25/4. That's the minimum value of the function. Last but not least, you want to solve and find any x-intercepts. So, take the value of the function itself, set it equal to 0. So x² minus x minus 6 equals 0. Now we can solve for this. We can factor this. You would get x plus 2 times x minus 3 for the factorization. That would equal 0. X would equal -2 and +3. So that means your x-intercepts are at -2, 0, as well as at 3, 0. Those are your x-intercepts, are -2, 0, and 3, 0. So let's go ahead and plot the x-intercepts right there. Now we just got to connect the parabola, connect the dots, and you have your graph of h of x equals x² minus x minus 6. So that's how you would do that. I still have more. just fix this graph here a bit. All right. Now, what's the next one? We have t of x is equal to 5x squared minus 10x plus 4. Alright, so t of x equals 5x squared minus 10x plus 4. So start by finding the coordinate of your vertex. Start with x is equal to negative b over 2a. Well, in this case, your b coefficient, which is the coefficient on the x to the first term, negative b, would that be negative of negative 10 over 2 times your a coefficient, which would be the coefficient on the x squared term, over 2 times 5. Well, negative negative 10, that's going to be 10. Over 2 times 5 is 10. That means x equals 1. So the x coordinate of the vertex is that x equals 1. Which also means that your line of symmetry is that x equals 1. So let me draw a dotted line at the line of symmetry. At x equals 1. Okay. Now, we want to find the y-coordinate of the vertex. So now we got to take that value of 1 we got for x, put it into the function. So you'll take t of 1, which would give you 5 times 1 to the second power minus 10 times 1 plus 4. Well, 5 times 1 to the second power, that's going to be 5, minus 10 times 1, well, that's minus 10 plus 4. Well, this gives us a final result with t of 1 being 5 minus 10 is negative 5 plus 4 is negative 1. So the coordinate of the vertex, point V, is going to be at 1, negative 1. So the coordinate of the vertex is therefore 1, negative 1. So let's go ahead and locate that. That would be right there, is 1, negative 1. That's going to be the vertex. And since this graph is going to open upward because the coefficient on the x of the second term is positive, we can therefore know the graph is going to open upward. So therefore, t of 1 equals negative 1. Negative 1 is the minimum value of the function. Now, last but not least, let's take this function itself, set it equal to 0. So we can find the x-intercepts. So we'll have 5x to the second power minus 10x plus 4. Set that equal to 0. Alright. Actually, we're not going to do that because that would require me to introduce to you. Sometimes that doesn't always work out, okay? At least not right now. We could solve for that, but that would require me to break out the quadratic formula, which we're not ready for just yet, or completing the square. We're not ready for either of those yet. That's a little more advanced in this course. So if it's something for now that you can't factor, if you can't factor it, feel free to find any other coordinate of x and plug in the values. So let's say we'll go with the classic one, t of 0. T is 0, well that's going to be 5, 0 squared is 0, minus 10 times 0 plus 4. 5 times 0 is 0, minus 10 times 0 is 0, so you get the point 0, 4. T of 0 is 4, so you would get the point 0, 4. Alright. Now, we got 1, so how about if we did T of 2? This one's going to be fun. What if we do T of 2? Well, that would give you 5 times 2 to the second power minus 10 times 2 plus 4. Well, 5 times 2 to the second power is 4, so you would get 5 times 4 minus 10 times 2 plus 4. Well, 5 times 4 is 20, minus 10 times 2 is 20, plus 4. Well, 20 minus 20 is 0, so you just get 4. So you get the point 2, 4. When T is 2, you get y equal to 4. When x is 2, you get y is equal to 4. So the point 2, 4 is also a valid point. And now we can draw our graph because we have enough points to connect the dots. And that would be your graph of t of x equals 5x squared minus 10x plus 4. Now, later in this course, we will be doing quadratic formula and completing the square to solve quadratic functions. But for now, we're not going to do that. I'm pretty much going to have to redraw the top part of the y-axis. Oh well. Cost of doing business, right? There we go. Alright, let's see. Capital G of x equals 9x squared minus 4. So we have capital G of x equals 9x squared minus 4. Well, we want to find the vertex, which is going to be x equals negative b over 2a. In this case, there is no x to the first term, so negative b, that'd be negative 0 over 2 times your a term, the coefficient on the x squared term, that'd be 2 times 9. Well, negative 0 over 2 times 9, that's just 0. So the x-coordinate of the vertex is at 0. Which means that's also your line of symmetry is at x equals 0, so that's the entire y-axis. Now, in order to find the y-coordinate of the vertex, let's go ahead and do capital G of 0. That'd be, basically, you'd have 9 times 0 squared minus 4. Well, 9 times 0 squared is 0, you just get negative 4. So G of 0 equals negative 4. So when x is 0, y equals negative 4. Therefore, 0, negative 4 is your vertex. So right here at 0, negative 4, that's going to be your vertex. And negative 4 is also the minimum value of the function because this graph is going to open upward. That's why we have a minimum value, because the coefficient on the x squared term is positive. Now, we can find... Yeah, we can do that actually. We can find the x-intercepts. So let's go ahead and do that. Set the function itself equal to 0. You'll get 9x squared minus 4 equals 0. Well, this is a difference of two squares. That's going to factor into 2x. What am I saying? That'll factor into 3x plus 2 times 3x minus 2 is equal to 0. So then you would get 3x equals negative 2, and then you would get 3x equals positive 2. X would equal negative 2/3. X would equal 2/3. So therefore, your x-intercepts are going to be at negative 2/3, 0, as well as at 2/3, 0. Those are your x-intercepts, so now we can go ahead and plot those. Negative 2/3 is about right there. Positive 2/3 is about right here. It's going to be a little bit more of a closed parabola, but that would be the graph of g of x equals 9x squared minus 4. Alright, let's see. F of x equals 1/4 x squared. So f of x equals 1/4 x squared. Well, again, start by finding the vertex of the function, which is going to have to be x equals negative b over 2a. Well, your coefficient for the b term is 0 because you have no x to the first term. So we know right away anything over 2a, that's going to, if a is not equal to 0, x would equal 0. Which also means that your line of symmetry is x equals 0, so that'll be the entire y-axis. So the x-coordinate of the vertex is at 0. So now you just simply put in f of 0 to get the y-coordinate. That'd be 1/4 times 0 to the second, which we know is just 0. So f of 0 equals 0. So the coordinate of the vertex is at 0, 0. In other words, the origin. So the origin is the vertex, and f of 0 equals 0, so 0 is the minimum value for this function because you have a positive coefficient on the x squared term, so it's going to open upward. Now I can tell you right now, if we go to solve for the x-intercepts of this, you're only going to get x equals 0. So that would also mean 0, 0 is the x-intercept. Well, we don't want to have just one point, do we? What I'm going to suggest is we pick a couple points and plot them. So let's start with, let's say, f of negative 2. That would equal 1/4 times negative 2 to the second power, which would mean that's 1/4 times 4. So that means f of negative 2 equals 1. So you would get the point negative 2, 1 as one of your points. So we can plot negative 2, 1 right here. Now, let's put in f of positive 2. So we'll do f of 2. That'll equal, let's see, 1/4 times 2 to the second power. So that would equal 1/4 times 4. So that means f of 2 equals 1, so therefore you get the point 2, 1. So 2, 1 we can also plot. So now we've got our 3 points. Let's go ahead and connect them and draw a nice parabola. And it looks like a bigger parabola than normal. So come Algebra 2, we're going to learn about shrinks and stretches and what those coefficients mean. We'll get more into depth with that when you have fractional coefficients. But for now, all you need to be concerned about is if you have a positive coefficient of x squared, it's going to open upward. If you have a negative one, which we'll get to in the next lesson, it's going to go downward. So I think I'm going to make this a 2-part lesson because there's so much to cover with this. And I have a lot of negative coefficient ones that I want to show you. So that'll be it for this lesson. Next lesson, we'll continue this into a part 2. And we'll have negative coefficients on the x squared. And you'll get to see what that looks like. So I hope everybody has a good night. Take care.